Hello everybody. So in the previous session, we went through the concept, or we went through the method to find the resultant and to locate the resultant of a non-concurrent flow system. So in this session, we'll be going to some important numericals, some important problems which are there in the notes. There are around 6 to 7 problems in the notes, and I'll be covering around 2 or 3 here in the session, 2 or 3 important and different type of numericals. And all of the problems are similar to the previous type. You can try it just by going through the notes. These are some of the important and different types of numericals. And out of all the problems, this is one of the numericals which is very important, which is the last one in the notes. I'll just read out the question. So according to the question, coplanar forces acting on a laminar is as shown in the figure. There are 3 forces, 3 kilonewton force, 7 kilonewton force, and again another 3 kilonewton force, where side of each square is 1 meter. Where side of each square is 1 meter. How many squares we have? We have 1, 2, 3, 4, 5, 5 into 5. So side of each square is 1 meter. Side of this square is 1, 1, 1, 1, 1, 1. And even side of all of these squares are 1. This is what is given here in the question. Side of each square is 1 meter. So you're supposed to find the magnitude, direction, and exact position of the resultant with respect to the point O. With respect to the point O. And this is the point. This is the point O. This is the point O. Now, steps will remain same. Steps will remain same. Hope you understood the problem. Side of each square is 1 meter. You have small squares here. Side of each square measures 1 meter. Side of each square measures 1 meter. Yeah. Now, steps will remain as it is. So step number 1 is to resolve all the inclined forces. Here we have 3 forces, and all the 3 forces are inclined. All the 3 forces. Even this force is inclined, this is inclined, and this is inclined. You have to resolve. Now, to resolve inclined forces, we need the inclination, angle of inclination of the forces, is it not? So, in order to find the angle of inclination, you can use this data. Side of each square measures 1 meter. Now, we need the inclination of this 3 kilonewton force. Let me write it as theta 1. Let me write it as theta 1. Now, how to find the value of theta 1? We can find the value of theta 1 using one of the functions, using tan. So, this is 1. This is 1, and even this is 1, and this is 1. So what is theta 1? Theta 1 will be tan inverse 2 by 2. So which is 45. Right. So we got the value of theta 1. Theta 1 is 2 by 2. 2 by 2. Done. Now, once you get the value of theta 1, let us go through. Let me mark this as theta 2. Let me mark this as theta 2. So you have 1, 2, 3, and 1, 2, 3, 4. So theta 2 will be 1, 2, 3, 4. 4 tan inverse 4 by 3. Tan inverse 4 by 3, which will be around 53.13. 53.13. Similarly, let me mark this angle as theta 3. This is 1, 2, and this is 1. So theta 3 will be tan inverse 2 by 1. 2 by 1. So theta 3 will be around 63.4. So we got all of these angles now. Theta 1 is 45 degrees. Theta 2 is 53.13. And theta 3 is 63.4. 63.4. So you can use the value, you can use this data. This data in the sense, side of each square measures 1 meter to find the angles. Which will not be given in the problem. You'll be finding the angles. Once you find the angles, once you find theta 1, theta 2, and theta 3, you can easily resolve all the forces into their horizontal and vertical components, is it not? So what's the horizontal component? Make sure that you draw the horizontal and vertical components exactly at the point of contact, point of application. So this is the point of application. Now this will be the horizontal component. horizontal component of this 3 kilonewton force will be 3 cos 45, and vertical component will be 3 sin 45. Right. Now, the horizontal component of this 7 kilonewton force, I'll draw it here, which will be 7 sin 53.13, and the vertical component will be, I'll write a minus inside the bracket because we'll be using it only till step number 4. In step number 5, you'll not be using the minus sign. So it will be minus 7 cos 53.1. Right. Now, the horizontal component of this force, I'll draw it and I'll write it somewhere here. So even here I'll write minus inside the bracket, minus 3 sin 63.4, and the vertical component, even this is minus 3 cos 63.4. Yeah. So we are done with step number 4. We have completed step number 4. Now, step number 1 is done. Step number 2 is to find, step number 1 is resolving all the forces into their horizontal and vertical components. Step number 2 is to find summation of all the forces moving along the x direction. You know how to find summation of all the forces moving along the x direction. We have 3 cos 45, 7 sin 53.13, minus 3 sin 63.4, and minus, that's 3 forces, 1, 2, and 3. You have 3 forces which moves along the x direction. Use it to find summation of fx, and similarly you find summation of fy. Using this, you find the value of r, which is square root of summation of fx squared plus summation of fy squared. Done. I'll not be solving this in detail. Hope you can do this. It's just a numerical calculation if you understand the steps. The only difficulty here is to find the angles. Find the angles. Using the data, using this particular data, you'll be finding the angles. Once you find the angle, it's easy. Step number 1 is to resolve. You can resolve each force into its horizontal and vertical components. You know how to resolve. And once you resolve, you can find summation of all the forces moving along x direction, summation of all the forces moving along y direction, and using these two data, you can find the magnitude of resultant. You're done with step number 4. Step number 4 is done. You got the value of resultant. Once you find the value of resultant, step number 5. Let me help you with step number 5. Step number 5 is to find the moment about reference point. Moment produced by all of these forces about the reference point. Reference point is O here. This point is the reference point. So we need a moment about the reference point O. Moment about the reference point O. Now, let us check all the forces. How many forces do we have? We have 3. We had 3 forces earlier, 3 inclined forces. So we have split all the inclined forces into 2. So we have 1, 2, 3, 4, 5, and 6 forces now. You have to check the compatibility of all the 6 forces with respect to point O. Let me check whether 3 sin 45 produces any moment about O. It will not produce, because if you draw the line of action of force, it will pass through O. And this is one of the conditions where force will not produce any moment about the point. So 3 sin 45 will not produce any moment about the point O. Let us go through the other force, 3 cos 45. Here the line of action is horizontal. Force moves horizontal to the right, and point about which we need moment lies below the line of action. So this force should produce moment in this direction, which is clockwise, plus 3 cos 45. 3 cos 45 into, what's the perpendicular distance? This is the line of action. 1, 2, 3. 3 is the perpendicular distance, 3 meters. Done. So we have completed this force. Let us concentrate on 7 sin 53.13. 7 sin 53.13. Check whether 7 sin 53.13 produces clockwise or anti-clockwise moment about the point O. Even this is horizontal, point lies below the line of action of force, and force acts horizontal to the right hand side. So this force should produce moment in the clockwise direction. So again it is plus 7 sin 53.13 into, what's the perpendicular distance? Again perpendicular distance remains the same, it is 3. Yeah. Now let us concentrate on this vertical force of magnitude 7 cos 53.13. Don't consider the direction, only the magnitude. So here line of action is vertical, and point about which we need moment lies in the left hand side of the force. Force is here. This is the force, and point O is in the left hand side. So this should produce moment in this direction. This is again clockwise, plus 7 cos 53.13 into, what's the perpendicular distance? This is the line of action. This is the line of action. Point O is here. This should be the perpendicular distance, which is 1. Now let us concentrate on this force. 3 sine 63.4. So here the line of action is horizontal. Force moves horizontal to the left. Force moves horizontal to the left. And the point about which we need moment lies below the line of action. This is the line of action and point O lies below the line of action. So this should produce moment in this direction. It's anti-clockwise, minus 3 sine 63.4 into perpendicular distance will be 1 into 1. Done. So we have the last force here, which is 3 cos 63.4. Now, here the line of action is vertical. Force moves vertically downwards, and point about which we need moment lies in the left hand side of the force. Lies in the left hand side of the force. So this should produce moment in clockwise direction. So it is plus 3 cos 63.4 into 1, 2, and 3. 3 is the perpendicular distance. So you have to find this to get the moment. Get the moment. Moment about the point O. Moment about the point O. So once you get the value of moment about the point O, it's very simple to find the x-intercept and y-intercept. It's very simple to find the x-intercept and y-intercept. D will be again the absolute value of moment about O here, reference point, divided by the value of R. We'll get the value of D. So x-intercept will be the absolute value of moment about O divided by summation of F y. So y-intercept will be again the absolute value of moment about O divided by summation of F x. If you do this much, it's done. So hope you are clear with this particular problem. This problem is very important. This is one of the important problems. Here will be given with a number of boxes, and it will be given that side of each square measures 1 meter. Using the data, you have to find the inclination. Angle will not be given. You'll be finding the angle using the given data. Hope this problem is okay and clear. Then let us concentrate and go through the next problem. We'll go through one more problem, which is the previous problem. This problem number 5 in the notes. Problem number 5 in the given notes, which is a simple problem in fact. So 3 forces are acting on a rectangular plate of dimension 700 into 375 mm as shown in the figure. So a rectangular plate is being given. A rectangular plate is given, and this side is given as 375 mm, and this side is given as 700 mm. 700 mm. And you have two forces, two inclined forces. So one of the forces is given here. This is one of the forces, and this is the other force, and you have one more vertical force which acts here of 600 Newton magnitude. Vertical force of 600 Newton magnitude, and this is 350 Newton, and this is 500 Newton. 500. These two are the inclined forces. So totally there are 3 forces. Now, let me finish the question. So this it's given in this way. This angle is given as alpha and this angle is given as beta in the question. And the division is given as this is 500 mm and this is given as 200. Now, if this angle is alpha, you can observe here, if this angle is alpha, even this angle will be equal to alpha, because this is the line of action. So if this angle is beta, even this will be equal to beta. So in order to go through step number one is resolve all the inclined forces. You have 2 inclined forces here. In order to resolve these 2 inclined forces, we need the value of alpha and beta. Is it not? We need the value of alpha and beta. So we can easily find the value of alpha and beta here using the given data. If you consider this as right angle triangle, this as one more right angle triangle, you can easily find the value of alpha. So if you just go through the drawing, the alpha will be tan inverse 375 by 500. And beta will be tan inverse 375 by 200. Okay. This is 375 by 500 will be alpha. Again, 375 by 200 will be beta. So once you get the value of alpha and beta, problem remains very normal. Problem remains very, very normal, right? So let me just tell you the values of alpha and beta. Alpha is 36.86. I'll write the answer here. Alpha is 36.86 and beta is 61.9. Beta is 61.9. Beta is 61.9. Right. So once you get the value of alpha and beta, you will be resolving the force into its horizontal and vertical components. The horizontal component of this force is 500. I'll write minus inside the bracket 500 cos 36.86 and the vertical component will be 500 sine 36.86. Here the horizontal component will be 350 cos 61.9 and the vertical component will be 350 sine 61.9. So we have completed step number 1. Again, here resolution is done. Again, angle is not given. You are supposed to find the angle, and finding angle is very simple here. Once you resolve, it's easy to find summation of fx. You can find the value of summation of fx. You have two forces which moves in x direction. You can easily find the value of summation of fy. You have three forces: 600 Newton which moves upwards, 500 sine 36.86 and 350 sine 61.9. Three forces. All the three forces are moving vertically upwards. You have to add all the three forces. And using these two values, you can get the value of resultant R. So by this, you complete step number 4. Step number 4 is also done. Now, coming to step number 5. Step number 5 is the next class step. Step number 5 is to find a moment about the reference point. Moment about the reference point. Here, according to the question, the reference point is point A. Point A is the reference point, and this point is the reference point. This is A. This is the reference point. Now, so according to step number 5, we have to find the moment about the reference point, which is A here. Moment about the reference point, which is A. Now, let us find the moment. This is point A. This is the point A. Now, these two forces, 500 cos 36.86 and 500 sin 36.86, will not produce any moment about A because both the force acts exactly on A. That it will be 0. Now, 600 Newton force. Check this force. When you draw the line of action of the 600 Newton force, it passes through A, is it not? It passes through A. When you draw the line of action of 600 Newton force, it passes through A. So even this 600 Newton force will not produce any moment. Now let us check this force, 350, or force of magnitude 350 cos 63. When you draw the line of action, again the line of action of this force also passes through A, so this force will not produce any moment about it. Now the force which produces moment about A is just a single force here, which is 350 sine 61.9. So here the line of action is vertical. Point about which we need a moment lies in the left hand side of the line of action. Left hand side of the line of action. So this should produce moment in this direction, which is anti-clockwise. Minus 350 sine 61.9 into the perpendicular distance is this. This is the line of action from here to here. This is the perpendicular distance, which is 700 mm. It is. So you'll get the moment in terms of Newton millimeter. Newton millimeter. So since you get the moment in terms of Newton millimeter, you will get the value of D, which is absolute value of moment about A divided by R as well in millimeters. Done. And you know how to find x-intercept. If you get the value of D, it's easy to find the value of x-intercept as well. X-intercept is the absolute value of moment about A divided by summation of Fy, and y-intercept is moment about A divided by summation of F. So I'll not be writing the values, I'm just explaining the problem here. Got it? So hope this problem is clear. Then all the problems are similar to this. These are the two different types or different problems available here in the set of problems. All the problems are easy, in fact, when you compare it with the previous set. Only this step number 5 is extra. Then hope you are clear with all the problems. Let us continue with the next concept in the next video session. Thank you.